So yeah, as I said before, today we'll focus more on the GitHub and we'll try to understand what it is. So just a few theoretical words about the GitHub. So GitHub, this is a versioning control system. What it does it mean? Imagine you are working in a small studio and you have, for example, 3 or 4 front-end developers and you are one of them. So you're working together, you're working in a parallel, and for example, today you need to fix, I don't know, styles for the header of the main page. And the second guy from your team does the same. But for you, it's necessary to change the font and for him to change the background color, for example. You are doing your part of job, he's doing his part of job. Now you push your code and here the magic happens. Without the control version system, your updates will rewrite his updates. So that means that he spends half an hour just for nothing, because his part of the code will just disappear because your file will rewrite his file. And here we have a versioning control system. What does it mean? We save our code, our database somewhere. So our project lives somewhere on the server, on the GitHub. GitHub, this is kind of storage for our code. The main benefit that this is decentralized. So every computer, every user which uses, every developer which uses the GitHub, it has the full story about our project. What happened, what piece of code was written, when it was written, by whom it was written, what kind of code was rewritten, what was deleted, what was added, and so on. This history, it saves on every laptop, on every computer of every developer. If you need to push something, you are making, you're working in a parallel with other developers, and if you are pushing something, you are pushing not to the code of other developers, but you are pushing on the server, on the main hub of your code. And this is a clever hub. It always compares your code with the code of other developers. And it can say, this is up to date, or this is not up to date, or maybe you have some conflicts because you touched with the same with your next developer the same piece of code, the same row of code, and now system doesn't know what is the up-to-date version. So your one is the latest one, or the code of your colleague is the latest one. Okay, I guess this is enough for the theory. We can start to work. Yeah, I will show you just basics. I don't want to overload your mind today with a different, understanding how GitHub works, what's the magic happens inside super deeply, and so it's not necessary for you right now, because as a junior front-end developer, you need to understand, well, the basics. You must be aware about the basics, and you must do your day-to-day job. It's not necessary to, I don't know, to install everything from the scratch. This is not your responsibility. Okay. Give me just a second. I will close all these Zoom windows because they are annoying. Okay, so here we are. This is my personal GitHub page. What we need to do? So here, if you open your profile, in your profile you can find, I mean, of course, in the beginning you register in a github.com. Okay, that's pretty simple. Then you have your repositories. We click on it, and here we have list of repositories. As you see, I am really perfect in the naming of my projects, but well, we will not care about it right now. We are pressing the new button, new. Here, we are making not any template or something, but we need to implement the name of our project. Let's say it will have a name test. Why not? Beautiful name, I guess. What we also need to do, every project have inside the Readme file. Readme, it has kind of documentation for the project, like what's the main goal of this project? It was created by whom? It was created on what technologies? What kind of goal do you follow? What kind of architecture do you have inside? And so on and so forth. So this is the file you must have. The second one, this is a git ignore. I will show it how it works a bit later, but we also need it. And choose a license. License, in a GitHub, it's possible to create a personal account, like, well, wait, a premium account and default one. I have a default one, but if you pay money, if it's really necessary for you, you can buy a premium account. What premium account guarantees to you? That you can select it private. So nobody else will have an ability to open your repo, your repository. We call it repository, the storage where you hold your project in a GitHub. And it will be impossible for them to copy your code and steal your code because, well, code costs money. Okay, and here we are choosing license. For us, the best one will be MIT. MIT means this is a free license. This is a freeware. People can take it, use as they want, and so on. I'm not really perfect with the licenses, so this is the license I ever use. I allow other people to use my code. That's enough for us. And description. This is our test project. Boom, that's enough. So now we press on the button create repo. Magic happens and our repository was created for our profile. Okay, so here we have code. And as you see here, we have HTTPS, we have SSH, and we have GitHub CLI. So this is different options to download your project. And for future, how will you upload your project? In the beginning, I highly recommend you to use HTTPS because with an HTTPS, what you are doing, every time you are collecting the data from the server or you are pushing your data to the server, you input your credentials like name or email, I don't remember, and password. That's enough. With an SSH, this is a bit complicated. You need to create a pair of open key and security key. These keys will live only on your machine. So GitHub will always compare these keys with what it has in its system. And if the open key is the same secret key, it saves only on your machine. If the open key is the same, you will be able to push your changes to the GitHub. Otherwise, not. Like if, for example, any of you will decide to push some changes in my project, it will be impossible because your SSH is different. Okay, but for now, this is a theory and we don't need it. Okay, so this is the link we will use to work with the GitHub. So just copy it. If you click on this right button, you will copy it. Okay, that's enough. For now, we are done with the GitHub. Now we are going on our local machine. Here we are opening the bash or command line or console, or on Macs or on Linux, you have your own kind of console. Yeah, in my case, this is a Git Bar. So you open it. And here we are writing the super simple command, git clone and our link. I'm not sure, is it possible to increase the size of these texts to make it? Yeah, I can. It will be simpler for you to read it. Look, git, clone, and my link. That's it. I press enter. Now magic not happens, my password. Okay, so now as you see on the left side, a new folder appeared. So I just told to my laptop, hey, laptop, there is a GitHub account in a GitHub. Please download it on my machine. GitHub said, okay, easy peasy, and downloaded it. Now we don't need it anymore. We don't need bash. We need to open kind of editor because we will write the code. Personally, I'm using the PHP Storm because, well, this is fancy, this is useful, it's powerful, and so on and so forth. Okay, here we have somewhere desktop. Here we have somewhere my projects, test, okay. And this one. So this is my folder. We have a license. As I said before, this is MIT license. And we have the Readme file. So as you see here, it's written test. First of all, we don't have a space here. How can we? Oh, okay, no, that's enough. This is our test project. Okay, let's imagine it's necessary to update. First of all, in this folder, test, will leave your project. I mean, your HTML files, CSS files, JavaScript, other folders, some files to build your project together, some backend stuff, images, fonts, everything will live here in this folder. And you will work with these files. Like right now, I will work with a readme.md. MD, this is also a text, kind of. So yeah, Imagine that we need to update our file. For example, a piece of code or something. In my case, this is just an easy Readme file. So here it's written, this is our test project. And we are adding more. No. Oh, yes, we can do it. Moreover, it's awesome. Yeah, so we save it. Now you see that my ID said that the name of this file is blue. I mean, the color changed from white to blue. Maybe that means something. We are going to terminal, and here we say, hey, Git, can you show us the status of the project? So this is Git status. And our Git says that file readme.md was modified and the .idea folder is not controlled by GitHub. So I will draw it. So this is our folder. Yeah. This part of files is under the GitHub. And this part of our files is not in a GitHub. So every file you can add in this list or in this list. So if you need this file to be built, to be sent on the server, because this is part of your website and it's necessary to show it to the users somehow, you, with a green arrow, you move it here in the GitHub, under the GitHub control. If, for example, you have a file which says to your system how to work with your application or how to open this application in the IDE, in the tool where you write the code. These files are absolutely useless for other developers because they have their own IDEs or editors, or call it as you want. So such files will move here, not inside the Git. It was the theory, now I'll tell you how it works. So do you remember we were creating the file gitignore. As I remember, we created this file. Nope. Idea. Nope. Okay. Bad luck. Let's create this file. So what is a gitignore? Gitignore will tell to the Git what folders and files we should ignore. New file dot git ignore. Gitignore. Boom. The task again. Perfect. So you see the green color of the file name, it means that this is a new file and it was added to the GitHub. But this is still not what we want. We need to add here an idea. Idea, this is the folder which my IDE, the PHP Storm, creates by default. And I definitely don't want to add this folder to my GitHub repository because other developers will use other IDEs or editors and they definitely not need my settings. So look, we created gitignore. We said that slash means folder. We don't need a folder with the name .idea. Okay, now we ask Git again. Git, tell us please about the status. And as you see, we have here the gitignore because we need it. We have readme, but this is a magic. .idea disappeared because now our system knows that it should not care about the .idea folder. Okay, now we can add the gitignore. What we are doing? We added new folders, new files to the project, but now it's necessary to commit them. Commit means to make a snapshot. Like we did something with the files, we need to save this state. Like we changed files, we update files, something was deleted, something was added, and we are doing the snapshot. Like right now, our project looks like that. This is a snapshot, and we call it commit. So we say git commit, then -m. -m means message. So when we are making the commit, we are writing kind of message. What exactly was done in this commit? Here we say readme was updated, for example. Yeah. Now, wait, git status. As you see, nothing changed. Nothing changed because I did not add my files to the commit. So commit said, I'm empty, I will do nothing. That means that we should add our files to the commit. How to do it? We can do git add, and then name of the file. If file lives somewhere inside children folders, we need to clone also the path. So here will be git add.getignore. Okay, does it work? Yes. Now we ask status again. And as you see, getignore is green. That means that right now it exists inside the commit. So if we commit something, we will provide the snapshot. And in the snapshot, the status of our getignore file will be saved. Okay, but well, copy every file by name. This is so silly. This is so long. Okay, so for this we can use git add and then dot. Dot in this case means everything. Please, GitHub, add everything to our current commit. Does it work? We are asking the status again. Okay, everything is green. So right now we can push our code. Yeah. So one more thing you need to know, because maybe you will find some differences in documentation. Many years ago, the main branch in the GitHub had name master. And right now it was renamed, I mean, it was renamed maybe 1 year ago to the main. So it was master, now it's main. If you will find the difference in documentation, well, now you know because of what. So here we will say git push origin and main. Why do we say push? Push means you have a commit. So, wait, we forgot about the commit. We added file to the commit, but we forgot to make a snapshot itself. Now we say git commit message and readme was updated. Readme like a file readme. Okay, now the snapshot was created. And if we ask Git about the status, Git will say that nothing changed, because from the last snapshot, literally nothing changed. Look, Git status, nothing changed. Okay, but the GitHub says that we have some commits. You see, we have some commits, and now it's necessary to push them. What means to push? We updated the code. We saved a snapshot on our local machine, but the remote server has no idea about our changes. And what we need to do, we need to push our changes to the remote server. How to do it? We are saying git push origin main. So our current branch has name main, and we are pushing to origin means remote. So we are pushing to origin server, to the remote one, to the master, to the branch main, because we can push to a different branches. About the branches, I will tell you a bit later. So boom, does it work? My super secret password. It still works. Okay, now we are going back to the browser. And look, I do not update my page, especially. So see, right now it's written test, and it's written, this is our test project. It's written here, you see? It was before update. Now I will update my page. Boom, you see? Moreover, it's awesome. This is our test project. Moreover, it's awesome. Because we provided a new piece of code. So we pushed our changes to the server, and right now our server knows about these changes. So if your next developer, I mean the developer next to you will want to update their code to take up-to-date changes, we can do it easily. Okay, but we were working with a main branch. Main branch, this is kind of super vital stuff where your final code and 100% working code is living. But for example, your manager comes to you and say, hey, we need to realize a new feature, and you have no idea how to realize it. So it's necessary for you to play with the code a bit, to make a small sandbox, to play around and understand will it work or not, and so on. You cannot do it in a main branch, because if you will push your changes to a main branch, there is a high percentage you will break something. This is the first case. The second one, you're writing your code, you think that everything is perfect, you're pushing your code directly to main, and you was pretty sure that everything will work. But this is not true. I mean, this is not how we are working in a development mode. We are not predicting. You're pushing your code, and new specialists are coming to the project. Their name is QA team. QA, they are responsible for the quality. And they press on different buttons. They see what will happen if the server doesn't respond, and so on and so forth. And they are finding the mistakes and problems with your code. And that means that you should take your code back and fix this code. But if you're working only with one branch, and everyone from your team pushing their changes to one branch, it becomes a mess. It becomes a hell. It's impossible to work with it properly. That's why do never push in a main branch. This is a super bad behavior. And right now I will teach you how to make it properly. So, okay, this is our branch. This is our main, but just in case. Every time you're opening the main, you need to do one thing. You are writing git pull origin main. What means pull? So push was sending the data to the server. Pull means collect all data to the server. And if right now some pieces of your code are old, redundant, or were deleted or something, you will take all changes from the server, and your changes, the local changes, will disappear. So if you change some pieces of code, but you did not commit, make a snapshot, and send it to the server, pull will delete it. On the other hand, this is really convenient because you say, I need pull, and that's it. And you take the new version of the whole project. You don't care, was it changed, not changed, what the status, you don't care. You just make a pull, and now you have absolutely up-to-date piece of code. I mean, the whole project, of course. So git pull origin main. Does it work? Yes, my password, of course. Okay, now it works. Perfect. So let's continue to work with the readme.md. The problem that I already said to you that we will never work with the main branch directly. Let's open the paint and I will draw it maybe. So this is the big point, and here we have a line. This is our main branch. Somewhere here, our manager came to us and said, hey, we need a new feature. We said, yes, of course, sir. And you create a new feature. New feature you are making in a new branch. This is a new branch. In a new branch, your code will work. You can make as many commits as you want. For example, you are changing, I don't know, some letters. This is commit A. Then you change, I don't know, 7 like a text to a 7 like a number, for example. This is also a commit. So commit number 1, commit number 2, there will be commit number 3, number 4, doesn't matter. And then you wanted to merge your code with the main, because you're not the only one developer which works with the code, because here Alex came and he did some changes. Here Sarah came and she did some changes, and so on. So main branch, this is the result of the job of the whole team. But let's come back to the new branch, which is yours. So somewhere here at this moment, you understood that you finished your job. This feature is working, everything is perfect, and you wanted to push your changes back to the main, because other guys, other teammates, they also need these changes for something. So you push your changes to the server. Now, what do we have? We have two branches, the master and yours, and we need somehow to merge it, to merge the code. So in the end, it will be main plus your changes. And this process, this one, this blue, we call it PR. Now I will open it. This is a pull request. I'm not sure that pull has this name, maybe not like a pull, but this one. I don't know. I'm really sorry. English is not my native language, so if I'm saying something wrong or stupid, please forgive me. So yeah, this is how it works. Let's simulate this situation right here. So what we are doing, we are writing in a console. So Git Branch. Git Branch will show us what kind of branches do we have right now. We have main. Okay. Git Branch B means create new. And here will be, I don't know, feature, update, Readme. Boom. No, maybe not B, but D. I don't remember. I was creating manually branches many years ago. Okay, plan B. So in a console, it's possible to create a new branch. I just forget how, but we definitely need it. Here we create a new branch. Feature. So yeah, how to create a new branch in a console, just Google it and 1 million responses will come to you. But I will do it in a different way right now. Feature. Feature, and here will be Readme updated. Boom. Look. Here in the bottom right side, there's written feature Readme updated. That means that we are right now in this branch. Okay, let's double check it. Git branch. So here you see we have two, main and feature Readme updated. Yeah, so as you see, I'm using feature, then slash, then a new name of the branch. This is just a name convention for the branches inside the GitHub, but you can focus on it a bit later. Right now, this is absolutely not vital. With a green color and with a star, it says where we are right now. We are right now in a Readme updated. Okay, let's go back to our code. So here we will say that's, I don't know, new branch result and some code. This code was added in a new branch. Brilliant. Let's commit it. Do you remember what we were doing to commit our code? We need to make a kind of snapshot, but let's start with the git status. Git status. You see, readme.md was modified. That's why we need to add it to the future commit. So now we are writing git add, and we are saying dot. Dot means everything. Please add everything to the git. Status. So you see, this is green already. It's still modified, but this is green. That means that if we will commit our changes, this file will go to the commit. I remind you, commit, this is kind of snapshot. So we are writing git commit m dash m. Dash m means message. Readme was updated again. Brilliant name, I guess. Okay, it was the commit number 1. Let's simulate commit number 2. Commit number 2. So we added some more data, yeah, to our file. Now we doing the same. We are writing git status. We see it was updated, but this is red. That means that it will not go to a new commit. Now we add this file. We write status again. Now it's green. That means that it will go to our new commit, and we commit it. Of course, where did I commit it? Readme was updated again, and here will be a new name. So instead of again, it will be once again, for example. Who cares? Now we are writing. Do you remember the name of our branch? Me not. So we are writing git branch again. We are copying the name of current branch because, as I said before, we cannot push our changes to the remote server to a main branch. We need to create the same branch there on the remote server. But right now, the remote server has no idea about the local branch we created just a second ago. And that's why we are writing git push origin, not push, but push origin. And here will be the name of our local branch, a new branch we created just a second ago. We press enter. We input our password again. Boom. Something happened, I hope. You see, here's it, a new branch. New branch was created because before our remote server had no idea about the this branch. That's why it created a new branch. If we will push once again our code to the remote server, to this branch, GitHub will already know that we are pushing it from feature Readme updated to feature Readme updated. Okay, that's enough from here. We are going back. Oh, my masterpiece. We are going back to the GitHub, and look, this super important moment. Please 100% focus on it. You see here on the top appears a new line. Feature Readme updated has recently pushed less than a minute ago. And here we have compare and make a pull request. Pull request, this is a process when you are trying to merge your code to the main branch, to the main code. Because I remind you, do not push your code to the main branch. This is illegal, absolutely. Police will come and slap you for this action. It's, well, forget about it. Every time you create a new branch and you make a pull request, this is how it should work. Okay, we press on it. Here we are seeing the description. A good commit always have the description. So what was done? The README file was updated with the silly text 2 times. Brilliant description. Here we can add reviewers, because if you have a big project, you have a lot of developers, and here will be, well, as usual, companies already provide you a GitHub account. This GitHub account always knows about people which take part in your project, and you will see the list of, well, these people. So you can add reviewers. Why do we need reviewers? Because you cannot just create a branch, push their code, and push it to the main. Because if you will break the system, someone will punish you. And that's why you must show your code to other developers, because it's a code review. Because, okay, you're professional. Everyone is professional, but this is human to make mistakes. That's why you push your code. You ask your colleagues like, hey, Jimmy, can you come here and check my code? Of course, not, well, literally, but inside the GitHub. They open this page. They open this pull request after I will create. And they will see that code is brilliant and we can push it further, or it's not brilliant and we must fix something. So you can notify these people when you are making changes with the reviewers block. Here can be assignees. Assignees, this is a person who is responsible for this stuff. You can be alone, you can be in a pair with other developer, doesn't matter. Labels. As usual, labels, what does it mean? Like current branch, current pull request is finished, or it's not finished because you are still working. You are just pushing from time to time your code just to check, will it work, not will it work, well, what happens, or you wanted to share this code with other developers, but do not push in the main branch. So here you can say different labels like half finished or 80% finished, doesn't matter. Okay, that's enough. Other stuff you will need not tomorrow. Now we create the pull request. Some magic happens. Hey, pull request was created. Look, right now this button merge pull request is green because you have no any conflicts. It has no any conflicts. How can we simulate conflicts? Let's imagine here, this is the main branch, yeah? Let's imagine this is the main branch. And I cloned this branch and set number 3. Jimmy, my next developer, took the same code and changed it to 4. So when the GitHub will take my file and his file, GitHub will see that we changed the same value. And GitHub, well, of course it's smart, but not as smart as we wanna. GitHub will ask us, hey guys, well, whose code is up to date? Because for me, we changed 2 to 3 in your pull request and 2 to 4 in your pull request. Which is the last one? Which value should be the final one? I cannot understand. And we call it conflict. If we meet a conflict, it's necessary to fix the conflict, to say GitHub like a small child, like this one you should delete and this one you should push. Unfortunately, you are doing it manually. Yes, but well, I hope you will meet your first conflict in a years, not earlier. So for now, you should know about conflicts, that it can happen. And if something will go wrong, if you see a lot of mistakes in the console, you will remember these words about the conflict and you will Google, how to solve conflicts in a GitHub, and you will find the answer. But for now, this is not vital. Okay, we are going back. Yes. So here, as usual, other developers are coming. Do you remember I was telling you about the code review? Other developers are coming here and they are saying everything is okay. Looks good to me. You can push your changes. This is really cool. Or they can say, total, well, Jesus Christ, what did you write? Please refactor it because this is not a code. This is, well, we don't know what is it. Anyway, they can say +1. +1 means a thumb up. Your code is perfect. Or -1. Sorry, dude, but you need to refactor your code because currently this is absolutely mess. Let's hope for the best. And someone said +1. That means this is super perfect. Of course, you cannot say same stuff for your own code review. But well, right now we are just playing around and trying to figure out how it works. That's why we can do any creative stuff we want. And we will see it in motion. Hey, everything is perfect. And one more. Okay, now we press merge pull request. The previous super vital moment was when you created the pull request, but now we will merge the pull request. One more thing. Let's open the new tab. Here will be the GitHub. Where's my repo? We open the test. Look, here we have branches, main branch and feature readme updated. You can check what inside every. So in a feature readme updated, we see a new code. But in the main branch, we still have our old code. And right now, when I will press the merge pull request, my code from my branch will go to the main branch. And from that moment, it will be the only one source of truth. It will be the up-to-date code. So right now, this is the main content. We merge the code. We come to the main branch, we update the page, and now we see all our changes in our main branch. You see? So this is how GitHub works. Plus the last drop, if you merged your code, actually you don't need your branch in the remote repository because right now it's useless. I mean, you had your changes, you merged your changes with the main code, and now your branch just exists for nothing, absolutely useless. So you delete it, delete the branch. That's it. So congratulations, we created a branch. We understood how to pull and push your changes. One more thing, look. We are going back to the local machine. We switch Git branch. So you see, right now we are on feature updated, and we need to go back to the main. I don't know the command. I mean, I don't remember the command, so we will switch it like that. Yeah. So Git branch. I understood. Git checkout. Okay, guys, I understood. When you need to change your branch to a different one, you write not like I was doing it before, Git branch and new name. No, checkout. Git checkout and the new name. So look, for example, we are going back to the feature once again. We are writing Git branch. You see right now the active one is a feature readme updated. Now I'm writing with the fingers manually. Git checkout main. Boom. And now our code said that we switched from the previous branch to the main branch. Git branch. This is main, yes, okay. But look, right now my readme is old. It does not have the changes we did because we merged my code from my branch with the main branch on the server, on the remote, but my local machine has no idea about what's going on. Do you remember I was telling you the piece of code you should write in a console to update your local machine to up-to-date version from the remote server? This is git pull origin and the name of the branch you want to update. I want to update my main branch, that's why I say main. Git pull origin main. Password again, super serious security. And you see here it says that readme was updated, and here 3 changes, 3 rows of code were updated. If we open the test, you see right now my code is definitely, absolutely, totally up to date. We have test, we have new branch results. This is the code we added in a new branch, and that's it. So today we understood how to work with the GitHub. What is a GitHub, for what it works, how to manipulate with it, and what's the difference between your local machine and the remote repository.